The range of paint tests that may be successfully carried out on site is limited by both the difficulty of handling complex laboratory equipment and by the lack of laboratory experience of most site personnel. In practice, the common tests which may be performed are viscosity check, to check suitability of flow characteristics and quantity of added thinners, wet film thickness check, to ensure that the film will achieve the desired DFT, visual checks on condition of paint, batch numbers, storage time, condition of paint container, label details, etc. Further visual checks can be made on the drying coating film after application, looking for coating condition, gloss, misses, pinholes, etc. Measurement of wet paint film thickness provides a useful guide for inspectors or paint sprayers to ensure that a correct and even film thickness is being applied to the article being coated. Use of a wet film comb at this stage of a paint application operation helps to prevent reject work, which in itself is time-consuming and therefore costly. The most common instrument for measuring wet film thickness is the comb gauge. It consists of a series of graduated teeth lying between two level outer ones. Combs with different scales are available. The WFT gauge consists of two end points on the same plane with progressively deeper notch steps in between. The instrument is pressed firmly into the wet film down to the surface and withdrawn. The two end points will be wetted by the coating material and may be some of the steps in between. It's important that the gauge is held perpendicular to the surface and not dragged across the surface. The WFT is measured and reported as the last wet step observed. If no steps are wet, the gauge needs to be turned to a different measurement range that can measure the WFT of that particular coating. Metric calibrated WFT gauges are also available, which give coating thickness measurements in microns. Wet film thickness readings should be taken as soon as possible after coating application. As soon as coatings leave the spray gun, evaporation begins and the percentage of solids by volume changes slightly. This is especially true of spray application where the coating travels through the air. Care must be taken that the instrument is not used on any surface irregularities that might distort the measurements. On curved surfaces, readings should be made along the length of the curve rather than across its width to prevent irregular wetting of the steps. The gauge must be wiped clean of all coating after each use to prevent the possibility of inaccurate readings due to coating buildup on the gauge. The gauge may leave marks in the coated surface that may adversely affect the integrity of the coating. Those marks should be immediately over-coated with fresh coating to avoid pinholes. Guidance may be provided by the specification regarding use of the WFT gauge. Some WFT gauges, particularly those made of thin gauge metal or plastic, may quickly lose their accuracy and should be replaced frequently. Dry film thickness, DFT, will normally be measured using an electronic or magnetic gauge. The instrument must be calibrated if accurate measurements are to be made. For best results, calibrate the instrument on steel whose surface profile matches the profile of the painted surface being measured. Using shims of known thickness, calibrate the instrument in the expected range of DFT to be measured. Access to a clean blasted surface is not always practical, and other calibration methods may be used. Calibration of the DFT gauges is an important issue and may be governed by SSPC, ASTM or ISO standards. These standards are discussed in the inspection module of this course. When a particular standard or method is required by the coating specification, that method should be used. In the USA, smooth calibration shims produced by NIST are commonly used. If gauges are calibrated on a smooth surface and then used to measure coating thickness over a rough, blast-clean surface, an adjustment must be made to ensure accuracy. One system sometimes used is to obtain a small sample of steel approximately 6 by 4 inches, 15 by 10 centimeters, and have this blast cleaned at the start of a project. This panel can then act as a reference panel as to the surface profile agreed and a calibration panel to check dry film thickness gauge measurements. The panel should be of similar material, i.e. steel alloy, and similar thickness to that of the structure being coated. Use and calibration of DFT gauges is discussed in more detail in the inspection module of this program. It is generally not good practice to measure DFT closer than 1 inch, 25 millimeters, to an edge, hole or inside corner. The probe must not overlap the edge of the sample being measured unless recalibration procedures are undertaken. Because MIO pigmented coatings are sometimes capable of inducing a magnetic error, DFTs cannot be reliably measured on some coatings, so it's important to frequently check the WFT during application. While this effect may not be common, it can create real measurement problems when it does occur. Application of coatings during poor weather conditions is likely to result in a lesser quality coating film and reduced protection. Quality control on site should monitor relative humidity, dew point temperature, and the temperature of the surface being coated to avoid problems with coatings being applied to a damp surface, freshly applied coatings becoming affected by moisture soon after application, coatings being applied when the temperature is too low for the curing reaction to proceed, coatings being applied when the surface temperature is too high and the film formation process is disturbed, coating solvents being unable to evaporate due to high partial vapor pressure. As a general guide, a specification is likely to require the following conditions. Air temperature is greater than 5 degrees centigrade, 40 degrees Fahrenheit. The surface to be coated is dry. Relative humidity is lower than 90%. Steel surface temperature is at least 3 degrees centigrade, 5 degrees Fahrenheit above the dew point temperature. If any of these conditions is not met, coating application should not be performed. Poor coating application is a major factor which causes failure. Typical problems resulting from faulty application techniques might include improper thickness, pinholes, overspray, holidays, discontinuities, pinpoint rusting. Almost all application-related failures are due to poor workmanship, though this may sound like harsh judgment. Poor workmanship refers to such practical issues as holding the spray gun too close or too far away from the surface, or at a significant angle to the surface being coated. These matters are largely a question of training or the lack of it, leading to a simple lack of understanding of what causes paint application problems. It is important that painters are trained in the skills of paint application, particularly those who are involved in the application of modern high-performance coatings. Good workmanship cannot be guaranteed. The specification must require good workmanship, and the inspector must be trained to recognize an acceptable quality of work. If coating is too thin, pinpoint corrosion can occur. If too thick, the coating may crack. High film thickness is likely to be a bigger problem than low film thickness, due to development of stress during the coating drying and curing cycle, and is more difficult to correct than low DFT. Over-thick coatings may retain solvent, leading to problems with cure and possibly to blistering in extreme cases. With polymerized coatings, particularly those intended to be applied at high DFT, 20 mils, 500 microns per coat or more, there may be internal shrinkage due to the excessive thickness, leading to cracking, flaking or delamination, loss of adhesion. Care should be used to ensure that the application stays within the recommended parameters, particularly film thickness. Coating should be applied in an even, uniform film, allowing coating to wet the surface. Use thin, multiple passes with 50% overlapping to achieve a uniform film and ultimately the final proper thickness. Special care in application is needed for control of single coat systems. Errors in coating film thickness applied cannot easily be corrected, and it is important to get the application right first time. Pinholes are small visible holes in a coating, often caused by application of a thicker organic coating over a porous surface. For example, coating epoxy over concrete or over inorganic zinc. Coatings with the wrong solvent balance may also suffer pinholing, caused by the inability of solvent to escape from the rapidly curing coating. High ambient temperatures may also lead to pinholing, as the film sets more rapidly. Fast-drying coatings such as vinyl or chlorinated rubber are most likely to suffer pinholing. The fast-drying surface does not allow the air entrained in the paint as a result of spraying or the solvents to escape. The name often given to this effect is gassing. The effect can often be seen after application of coatings as a form of bubbling, rather like the surface is boiling. Applicators may apply a thin coating, able to penetrate the porous substrate. These materials, when specially designed, are called tie coats. Alternatively, thinning the first coating with up to 50% thinner may help penetration of the substrate and achieve better adhesion. Overspray occurs when the spray gun propels paint onto another surface which was not intended to be painted. This is most likely to occur when the applicator fails to trigger the gun, continuing to spray paint at the beginning or end of each stroke. Overspray generally adheres to the surface it reaches, leaving a rough surface. The main problem for the applicator is that coatings are applied to surfaces where it is not appropriate. The coating is likely to partially create a film, forming an ineffective barrier. Dry spray usually leaves a rough surface, which looks like abrasive dust in the surface of the coating. The dry spray is poorly bonded to the painted surface and may, in some cases, provide sufficient dusting to prevent adequate bonding of the next layer of paint, leading to an adhesion weakness in the system. The problem may be compounded by the entrapment of real dust and other contaminants in the rough surface of the dry spray prior to the next coating operation. Dry spray is most likely to occur when the painter is working at some height and the escaping paint particles can fall, drying as they go, or when the wind is blowing and paint particles can be carried by the wind. The applicator should ensure spray gun is properly adjusted and apply coatings at the optimum distance to surface. The coating should be fluid when it reaches the structure and wet the surface with good flow out. Coating should generally be applied in several multiple passes, overlapping 50%. Holidays are bare spots, misses, or even thin spots in a coating where the substrate is uncoated. They are generally more significant when the coatings are linings intended for immersion service. Pinpoint corrosion can occur, and premature coating failure is likely to be associated with any holiday. Poor workmanship can encompass many factors of application faults, any one of which could cause or promote an active coating failure. Applying coatings over visible contamination, applying coatings improperly, either too thin or too thick with runs and sags, with pinholes, overspray, etc., could all be corrected or avoided with better application techniques. Poor workmanship can be overcome to some extent by training. This subject is discussed in some detail in the advanced module. Proper training is essential, however, if the trainee worker is to become part of the team. Workers should be given the opportunity to understand the effects of workmanship on coating performance. It should then follow that they will develop confidence and pride in their workmanship that can go a long way to offset any application faults that reduce the life of the coating and lead to a coating failure. The coating inspector must pay careful attention to the spray application of coatings. Many coating defects originate in the spray application phase of the job. Proper equipment, procedures and techniques are essential to a successful spray application of any coating. Equipment for spray application should be examined to determine whether it has adequate pressure regulating devices and accurate gauges. In this connection, the inspector should be aware that the single pressure regulator and gauge found on many coating pressure pots controls only the pressure within the container and not the pressure of the air that atomizes the coating. With a single regulator, the atomizing pressure will be equal to that at the receiver of the compressor, minus the pressure drop in the hose lines. If the receiver pressure cannot be controlled to suit spraying operations, an additional pressure regulator must be inserted in the line between receiver and spray pot or between gun and spray pot. Hose lines for spray equipment should be of large enough diameter to prevent excessive line drops in pressure, and compressors should be of adequate capacity to handle all air tools and equipment being used at one time. The interior of the fluid line must be clean. Traps and separators for removing oil and water from the compressed air source should be operating and effective to ensure that the air does not deposit visible oil or water on the surface. The quality of spray air can be checked using the blotter test, ASTM D4285, just as in checking the quality of abrasive blast air. Spray guns should be kept clean and in good working order. The air cap, needle valve and fluid nozzle for spraying a particular coating should be in accordance with the coating and spray equipment manufacturer's recommendations. The coating deposited within the spray pattern should be inspected for uniformity of distribution. When zinc-rich coatings are used, spray pots should be inspected for adequate agitators necessary to keep the coating in uniform suspension. If these are not provided, the coating must be checked to see that it does not settle. Mechanical agitators should be used when material containers of 5-gallon, 20 litres capacity or more are used. With airless spray, the operator or helper should check frequently that mixing is adequate to maintain the coating components in suspension during the spray application. In conventional spray pressure pots, the mixer may be an integral part of the design. The pressure pot agitator should be used only to keep coating material components in suspension, not as a primary mixing device. Working pressures for spraying should be no higher than are necessary to obtain satisfactory atomization of the coating, since high pressures may result in excessive fogging and overspray. The ideal distance between spray nozzle and surface can vary depending on the equipment used, but should be kept uniform, and the common habit of supplementing the painter's reach by increasing the spraying distance should not be permitted. The technique of the operator and the adjustment of the gun should be observed for any deficiencies that would result in non-uniform coating thickness. The use of the wet and dry film thickness gauges to point out areas of widely varying film thickness will generally have a very beneficial effect on the efforts of the spray painter to deposit uniform coatings. The dry film thickness gauge should be used to determine the final acceptability of the coating. The inspector should pay particular attention to the spraying of crevices, corners, welds, bolts, rivets and sharp edges, since these areas are generally slighted in spray application of coatings and cannot easily be checked with a film thickness gauge. Surfaces hard to reach by spray application should be brushed or swabbed with coating. Some coatings have a tendency to bridge across instead of fill cracks and crevices in the substrate. If called for in or allowed by the specification, a stripe coat should be applied to cracks, crevices, welds, etc. Stripe coating consists of brushing the coating into cracks, crevices and corners, etc. in order to work the coating into the narrow openings. With regard to coatings application procedures, some of the coating inspector's responsibilities may include determining that proper application equipment and coating materials are on site, including pressure pot with agitator, pressure regulators and gauges for conventional spray equipment, spray pump for airless spray, appropriate quality brushes or rollers, hose lines, air and fluid if necessary, moisture traps and oil separators, spray guns. Other responsibilities may include observing and verifying procedures for handling coatings, including mixing, thinning, agitation, safe storage, shelf life. Observing application techniques, including proper working pressures, uniform distance from workpiece, specify WFT and DFT are achieved, proper coating of hard-to-reach areas, review of safety issues, including fire hazards, breathing equipment, MSDS information available. The inspector needs to ensure his or her own safety. This is best accomplished by knowing and following the job safety rules.